You got a front row seat, AJ. You got a front row seat.
Yeah, of course, man. I would never not.
Thanks for coming.
Yeah.
You made it.
That's the one.
Okay. But now for real. Hopefully, right? No, thanks for coming. Ready? Let's do it.
I'm going to come in from the other side because of the cables.
Okay, cool.
This is our 315th session. Now, I know it says scaling event-driven architectures with serverless micropayments, but what I like to call it is a story about passion, about how we find technology, how we connect with it, and how we really are drawn to actually learn more, to be able to harness the power that we all explore. Brian, during the pandemic, really had a passion for technology from marketing. And just said, like, this is what I want to do. These are the people that I should be with, and this is the technology, and this is the thing that really is going to propel me to do better in the feedback. So with that, I'd like to introduce you to Brian. Brian, take it away.
Thank you. Awesome. Thanks everybody for coming. This is really exciting. I'm going to use my clicker. And this is Dev 204 Scaling Event-Driven Architectures with Serverless Micropayments. So that's a lot of words. So we're going to deconstruct this over this talk. And we got the slide room. So just to lay the scene a little bit. So I don't know, were any of you all here at reInvent this past year? Okay, got a few people. So I gave a DevChat talk about this platform that I built called Capital Platform. It's a social media meets blog writing, now meets monetization platform. And what we presented was, it has a bit of a backstory. So I joined the team back in June of 2021, and that was just doing front end. And the team said, we have this Angular build, runs on Google Cloud, and can you help us build this social media platform? So I'm thinking, I don't know, can I build a social media platform? So I just joined as a front end developer, and we wanted to migrate to AWS. I had become an AWS community builder at the time, and I was starting to learn more about the AWS ecosystem. I was like, oh, these are a lot of cool tools, we should probably use them. We were like, okay, we should probably use them. So then I started building, and then it was like, why are we building in Angular? Let's use React. I like React. So then we moved to React. Because you think like one front-end migration, one back-end migration, let's just have all the migrations. So what that ended up becoming a year later was what I presented at reInvent, which was a fully functioning social media platform. Then, fast forward to February of 2023, we did sort of this big beta launch. We got like 600 users, well, 500, it's now 600, it's pretty exciting. We have about 50 beta customers, and then we have like a huge database now. So there's like hundreds of articles, there's thousands of posts, a lot of people engaging in this. And this is sort of like when you're building something for the first time, you never know when it's going to reach scale. But it was just very exciting to see people actually engaging with this platform that I had been working on and building for our team. So that was just really our way of bootstrapping to the cloud. And I would say if there's ever any idea that you want to build in this world, you should definitely build it. I'm really happy that I have a supportive team of people that inspired me to build. So I always try to give that to everyone else to say if there's an idea that you want to build, you should 100% build it. Now, if you build something, your users will ask for things. So we build this platform, and now we start getting feedback, and then we think, okay, so like I'm a user, I have my profile, but what can I do with it? Could we do tipping? Could we do like making a business out of the profile? And I'm thinking like, I don't know, can we do that? And if you've ever used Uber, has anyone used Uber to like do ride sharing? Okay, anyone use Lyft? Those types of ones, right? Anyone use Venmo? Venmo people, okay, PayPal. Okay, yeah. So if you've ever used any of those platforms, it's very revolutionary how they've been able to make payments accessible. You know, you use a bank, but it's sort of creating like a mini bank that then can work with many different types of users. So what we're going to talk about is how you can build this on your own. But this was where it's like you want this as a problem, where you've built a platform that people are enjoying and they're liking, but now they want it to do more stuff. So then that becomes more work on the dev side, but that's why we're developers. So in my talk today, we're going to be going through 5 core areas. I want to deconstruct serverless and serverful architectures with you, just to give some context. We're going to then do event-driven architectures. We'll then talk about how I introduced serverless at the Capitol. Then we're going to talk about why serverless just makes sense and why it's really cool. And then we'll do some future considerations so that when you leave this talk, you'll also think, okay, I understand serverless, but I also understand serverful and where I might want to use one or the other. And by the end of it, hopefully you'll see why serverless is so revolutionary and why I'm such a big fan of it and why we adopted it at the Capitol. Okay. So just a little bit about me. So I'm a software engineer and a co-founder of the Capitol platform. I'm also a very proud AWS community builder. So was ever AWS Heroes or community builders? This was a program that helped me a lot. I joined this actually during the pandemic, and I highly recommend this to anybody that is interested in making content about cloud and just wants to learn the services from the people that actually create them. It's been a hugely helpful program for me. I'm also a creator of the Tech Stack Playbook, which is my own YouTube channel and dev shop. And I have a podcast too if you like podcasts as well. And I also got into tech through a lot of hackathons. So that was really this open source, building in public, learning as I go, not necessarily knowing all the answers, but figuring out as I go. That's really how I got into tech. So first up, let's talk about serverless and serverful and where you might want to use either. So this is a very interesting story. If anyone followed the Amazon Prime video, I see some head nods. If you know the story, you know. It's one of those if you know, you know. So we're going to talk about that. This was really interesting because there was this blog post that was penned by the Amazon Prime Video team, and basically what it was saying was that they were just migrating and re-architecting their video service from a serverless approach with Lambda functions to a serverful, sort of containerized server approach. And it was very, very, very controversially, people were engaging with this on social media because, you think about step functions, you're talking step functions, Lambda functions. These are things that we all know about. And then, Prime was moving away from that. And there's a reason why, but it was just very interesting because there's a lot of auto-scaling considerations that you might want to consider if you're going to take this approach or not. So basically all it meant was that, hey, we're going from serverless, which is Lambda and step functions, to a monolith, which is using Amazon EC2 and Amazon ECS. So just going from serverless to serverful. And they listed a lot of reasons, like lower costs. It was expensive to run this service with Lambda functions, so they wanted a more server way of doing that, and also to scale against bottlenecks. It is important to note, though, they did talk about it being a good choice when they first started this out. And I'm going to come back to this because this is really important. When you're building a service, you need to get started. Because when you're building anything, this is something that I very passionately and firmly believe, time and complexity are your 2 biggest obstacles with building anything. So if you can get your code or your features into the hands of your users, it's almost like it doesn't exist. And we've, I'm sure, spent months and months building features and maybe it didn't get shipped to production or maybe it got changed and it's on backlog. If you can't solve the time and complexity problem, it's not going to reach scale, it can't reach your users. So serverless is a really great way to start building because then you can actually start having wings and fly before you know how to. So let's talk about event-driven architectures next and where this fits into the pie. So I want us to think about event-driven architectures as being really 4 core considerations. The first consideration would be streams. The next is flows. Throw in if this then that logic, and then schedules. This is really all that you need to think about in terms of event-driven architectures at a baseline layer. And event-driven architectures become many different things, but this is at least how I like to think about it in terms of categories. Now the categories become a little bit more complicated when we start throwing in services because we want those schedules, we want those streams to start doing things. So we use Amazon DynamoDB as our database. You can use DynamoDB streams. What's really cool about that in terms of a database model is, let's say that on update of a record, I want to run a function that updates something else. So when we have a like function, for example, every time that a user likes a pose, that's a creation of a like event, and then it's finding the corresponding post object and then giving it a +1 or a -1 if you unlike. Lambda functions, step functions, and then function URLs. We use those in our serverless payment architecture, which I'll walk through in a little bit. AppSync, huge fan of this as a service. This is basically your graphical transformer. It wraps really nicely into AWS Amplify if you use that as a framework. Very, very powerful, because then you can just run just literally graphical transform, and that's what it's doing behind the scenes. But then it's going to generate your schemas, for your queries, your mutations, your subscriptions, anything you need. Event Bridge, that's if you want to do cron operations, so time-based schedules, and then queues with SQS. There's a lot of services, but these are sort of like if you wanted to have a list of the services and what they can do, that'll be really helpful to sort of frame this up. So now, since we're all techie and trendy, I feel like we kind of all want to use large language models because that's what the cool kids on the block are doing. So that's what we're going to do. And I didn't have access to large language models when I started building this for the Capital, so we have to go back about a year when I started architecting this out. But if I were going to do this today, I would 120% be asking a large language model, what do you think about this consideration? I have this architecture design pattern. Is this validated? Can I test against this? So that's what I kind of am trying to model here. And I also wanted to test to say, like, would a large language model like what I thought about? So I threw in the same prompt, and it's important to do the same prompt for all the different large language models. So I was basically saying, I'm giving a talk on deconstructing event-driven architectures with serverless micropayments. You know, is this valid? Would you go a serverless approach, or would you do a serverful approach? So I kind of wanted to also test myself and say, like, did I make good decisions and considerations when I started? So I asked OpenAI ChatGPT, and I threw in that same thing. It brought up a bunch of different things that was interesting. Specifically with Serverful, you have larger control over the environment. You also can maintain a persistent state, such as with containers. There's also layers of abstraction that you don't really have. But you also have to manage the server, so you have to do a lot of management and patching and updates and those types of things. There's significant upfront investment and ongoing costs, especially with maintaining. Has anyone worked specifically with containers and servers? Okay, a lot of hands. Okay, yeah. So I'm sure you might know that there's a lot of work that goes on behind the scenes. This is no surprise to you. Now, I also asked it, what do you think about serverless? So it talked about how, pay-as-you-go auto-scaling. There's a lot of these core benefits that we hear about serverless approaches. It did also talk about cold start issues and also maximum execution time, which for Lambda could be 15 minutes. And then also, you have less control over the environment. But at the end of the day, ChatGPT still did say that it makes sense if you're doing serverless event-driven architectures to use a serverless approach, because then it eases operational bandwidth, and it also makes it really easy to build upon and get a model that you can work from. So sort of like 1 out of 3. Now I asked Google Bard, what do you think about the same thing? So it brought up literally the same pros and cons list, and by the end of it, it was saying that serverless does make sense because it can scale your applications, it can allow you to scale services independently. It can also be easier to debug and troubleshoot problems. Because if you think about it as like a microservice, you're editing like a specific feature of your backend. You don't need to reconfigure the whole system every time. That's also very important, and also interesting that Google Bard picked up on stuff that OpenAI ChatGPT didn't. So this is where you can get many perspectives and then sort of build a schema around your decisions. So then I asked Hugging Chat, and they sort of had the same pros and cons list. But what was interesting was that it actually had a much more ambivalent answer to which one is better. It didn't really have an opinion. It said that you could do really both. You could do one or the other. And that's true. It really depends on what your skill level is and really what you're interested in building. So there's not really a right answer. It's more of a what's the right answer for you if you're the one who's building it or your team. So now introducing serverless to the Capital. So this was when I was doing a lot of research. There were quite a lot of great AWS Community Builder webinars and trainings. I got to talk to a bunch of different people at AWS. And I thought, okay, Kubernetes and clusters, not touching that with a 10-foot pole. Let's try to do serverless. So where we sort of came into the play was, okay, we have our user base, and there's about 4.2 billion social media users globally, which is that's a lot of people. Now, the problem with what ends up becoming content creation, there's the content creators grind, is there's 46% of full-time creators make less than $1,000 annually. And that's a stat that's pulled from Linktree's 2022 creator report. This is really fascinating because I know a lot of people, I have a lot of friends that are very big social media content creators. it's very hard to make money on social media because ad revenue doesn't become what you'd expect, and it becomes hard to build a business around that. So this is something that we wanted to fix. We wanted to see a way where we could turn our users' profiles into a way that they could then generate businesses. And also just empower creators to create and earn. Not just create and earn. So that's what we were really set out to do. So put on your business consulting hat, we're thinking we want to make our profiles have utility. As I'm sure you've been in meetings where your managers or your team say, give this feature utility. But what does that really mean? So we wanted to give our users an easy to scale payment methodology. Okay, but then you're wondering, Brian, well, what does that mean? So we're going to go through that. So in our endorsements payments flow, I'll show you the front end and then I'll show you the back end. So on the front end side, when you go to a profile, this is my profile. So you click on, you see, and then you can see in the middle that it says endorse. So that means that I have monetization set up. So then what you'll do is that you will add an amount, so like $10 right there, and then you'll put in your payment details in that little box right there. What this is going to do is it's going to tokenize the payment method and then what the corresponding value is along with your information. That's then going to go up through our payment system through Lambdas, is then going to fire off in Stripe, and then it'll either give back a response that it was successful or not. And then once that's happening, there's going to be a bunch of other stuff that's happening behind the scenes. But this is what you see. You don't need to worry about the databases being updated and Stripe doing its thing and Lambda doing its thing. It's really just, was it successful or was there an error? And if the payment went through successfully, you see some confetti. We like confetti. I throw confetti into everything that I do front end, just makes it so much more fun. And now the payment is successful, and you can review that the payment executed. So what's going to happen is you're going to get a notification as the endorser. That's going to get sent to your list of tips that you've given, and you'll get an email. Now, I, as the receiver, since you gave me so generously and so nicely $10 just now, I'm going to get an email that you did that. I'm going to then get a list of all of the tips that I've received, so you'll be added to that. And then I'm also going to get a notification that you gave me $10. So now you're wondering, okay, what's happening actually behind the scenes? And there's actually quite a lot that's happening behind the cloud. So now we're going to go through a map of our solution architecture and how this system is actually running. So you're the user. You are going to hit our AppSync API with all that data that's going to get tokenized. Now that's going to hit a Lambda function. It's going to then hit Stripe, and Stripe's going to say, this payment executed or there was an error. And that could be like balance not allowed, the credit card could be invalid, could be some sort of information that's missing, maybe like your credit card number was wrong, but it'll let us know like if there is an error, and then the front end gets that as a response. Now what will happen is, if this is successful, and this is showing that if it was successful, now my profile is going to get updated to the amount of money that you gave me, and then also your sender profile is going to get updated with the amount of money that you gave. Now, because it was a valid payment method, and it was a valid transaction, now we're going to enter a function URL. Stripe is then going to tell another Lambda function that this payment went through. All of the corresponding data from the previous event carries over to this event in terms of the way that we map metadata. Now, AWS SES is going to then send you an email that you sent a tip. I'm going to get an email that I received it. And a great thing about, just going back, with SES, you can do templates. So then you can pass in data into the template. And I've always wondered about how to do that. So SES provides a really great way to build with emailing, and then just pass in metadata accordingly. So then I'm going to get an email, or I already got the email. I'm going to get a notification that corresponds to that email that I got, the notification. And then your list of tips sent is going to get updated, and then my list of tips is going to get updated. So all of these event-driven architectures are all happening behind the scenes. And this is what it looks like really at scale. This is like a very scoped down example of how this is working, but it's like different Lambda functions firing off, and then the event of one Lambda function will then be making another event happen from another different service. And I think this is really interesting because you can have user-initiated events, but you can also have other third-party initiated events. So you could have Stripe sending data to Lambda securely, and then that can cause an event. Or a user could initiate an event with our API. So just a couple different ways that you can have event-driven architectures causing certain things. So why does serverless and Lambda functions just check a lot of boxes for us? So what's really interesting is that we're able to send emails with SES, update user profiles, verify payments. We can notify users of those payouts, and we can create logs of those transactions. it checks a lot of boxes for us. And you can literally just update the IAM role so that the Lambda can assume an SES role to then send emails. It can also assume a role to update a DynamoDB table. You can also, if you needed to update or validate some sort of authentication, you could hook it up to Cognito. There's a bunch of different ways that you can configure your Lambdas to speak to your AWS resources, and then that's where it all becomes event-driven architectures because it's all speaking the same language. Now, why does serverless just make sense? I mean, I kind of just explained why it makes sense to us, but why should you care about serverless, right? So, in terms of what serverless allows you to do with scaling up, these are the three areas that I think matter the most: speed, cost, and scale. And I'm going to dive into why those are so important. But when you're building features, again, remember from before, time and complexity are our two biggest problems. What we need to do is we need to solve for that with three solutions. So we need something that's fast, we need something that isn't going to really burn a hole in our wallet, and also something that can scale and can be basically allowing us, we don't necessarily know the bandwidth that we're going to need, but can work with us when we don't have all the answers. So in terms of speed, so it allows us to build these minimum viable features, or MVFs, very, very fast. And what that means is that you don't need to provision a server and make sure that it has the certain amounts that you can get reads and writes and updating and all those types of things. You can just allow this Lambda function as a managed service to then be running and then pick up what it needs to and allow you to process all the stuff that you need. Now, cost. You only pay for what you use and what you need. The one thing that is important about Lambda functions, though, is that you want to limit the amount of time that it's running. You're going to run up a pretty big bill if Lambda functions are running basically for a long period of time. So if you can have mini Lambdas that can run certain stuff, that is a way where you could ease the cost of your Lambda architecture. And then you're also only paying for certain invocations. Then for scale, you can extend it to the millions of reads and writes. I would say that if you reach the millions, either something really great or really bad happened, but the Lambda team did actually something really interesting recently where they have now tooling to prevent recursion. So I thought this was a very cool, this literally just came out a couple of weeks ago in a blog post, but then you don't really necessarily have to worry about recursion because it'll auto-edit, basically end the function. So we're going to assume that if you're reaching the millions, you're doing something right, and Lambda will let you scale with you. Now, what are some future considerations here? Because we adopted this serverless approach at the Capitol, but will we always be using this? Will we always need to do something like this? This is something that I'm thinking about, and sort of where do we go from here, right? I mean, I constantly am checking the architectures that I build, and I try to think, did I make the right decisions? Did I not? Try to be agile. Sometimes I was in a chalk talk earlier talking about AI, and just the need sometimes to edit your filters, your models, sometimes the query parameters that you're looking for, just different types of data sets. You need to sort of be able to edit and be agile. And this is something where I try to not necessarily think that I have the right answer. I think that I might have the right answer at the right time, but that this always can be changed. So what we can do is that, let's say that we wanted to edit our architecture, or we wanted to add in new services or new architecture patterns. So what we can do is that we can use any of these infrastructure as code type CLIs, and then this will allow us to build serverless backends or serverful backends, depending on what we need to do. But AWS Amplify we use at the Capitol, CDK we've used at the Capitol, editing CloudFormation directly we've used at the Capitol. I've also used AWS Serverless Application Manager, also known as SAM, and then the serverless framework. These four are basically just abstracting complexity away from CloudFormation. I didn't necessarily think about it like that, but I was diving a lot into very niche CloudFormation issues this year, and then I realized, and I was like, oh, we like abstractions, and we talked about that earlier, about just the need to abstract. It's too complicated, right? Sometimes these tools just really help us scale. But what you just need to know is that these tools are just abstracting a very long YAML file that's CloudFormation. So what we do at the Capitol is we're going to add a function with amplify add function. Then if we want to update it, we'll do amplify update function. What we'll then do is if we need to add a custom resource, we can do amplify add custom. Then we can also edit the CloudFormation directly. And then we can also when we get everything the way that we like it, we'll then do amplify push. And what that's going to do is that it's going to run a whole bunch of different CloudFormation updates. It could do create. If you're removing a resource, it could delete that. But this is sort of the pipeline that we use as infrastructure as code to update our resources or create new ones. So now where might we go from here? So if we need a feature, serverless. If we need another feature, maybe update that serverless or add a new one. Maybe we'll add a new Lambda function. Maybe we'll add something with event bridge, like an event bridge rule or an event bus. we could do any of those number of things all day long. But it might become a case where we really need to have a designated server running that is able to containerize a lot of these services. So maybe we might be looking at ECS or EKS, and these are things that I'm actively looking at right now. I do think that when you're building, you should be building ahead of technology that you might not need to know now, but you might need to know in the future. So you try to get like a 6-month or a 12-month window into what you might need to do in the future. So that's what I'm doing right now. I'm like definitely not like super interested in migrating everything to an EKS or ECS setup, but I do have to see that on my radar as like we could possibly do this. And you don't want to have a message from your co-founder or your manager saying we need to completely redo our architecture, and then you go, well, I don't know how to do that. So you kind of want to get ahead of the curve there, and that's kind of what I'm trying to do right now is think like, okay, serverless got us here, well, we always need this. So then I'm thinking ECS, EKS, or maybe EC2 instances. Designated instances, auto-scaling, predictable requirements, burstable compute needs. This is sort of the flow. I'm very happy with serverless, I'm very happy with it, but I do have to plan in that where maybe we might need to move to something else. And you might need to too. And if you need sort of a serverless toolkit to at least get started, I think this slide is going to be really helpful and important for you because these are the tools that you could use for infrastructure as code. So Amplify, CDK, SAM, Serverless, CloudFormation, those are all different ways to use infrastructure as code. And then what you can build with that, you can use DynamoDB as your database, you could use Lambda for those serverless backend scripts, you could use AppSync for an API. We like GraphQL, so if you like GraphQL, you can use that. EventBridge, if you want to do events, and then SQS, if you want to do queues or batching. So these are really great tools and methodologies to be thinking about how to build serverless. And again, I really do like the Amplify and the CDK. Those provide really great options, but you can always edit the CloudFormation template directly. And knowing that skill, if you're able to talk to anyone at AWS or some consultant or developers who have written CloudFormation directly, you should probably try to pick their brain because they probably have very interesting ways of how they think about CloudFormation. It gets abstracted with the CLIs, but you will still need to know CloudFormation if you're doing that type of stuff, at least at a baseline layer. So, we went through a lot in the last like 25-ish minutes, but let's kind of go a little bit of a review of what we discussed because we went through quite a lot of things. We went through a serverless versus a serverful approach, and I do also want to emphasize with kind of like a business consultant voice that it depends, because it does. We got to see an example where a company migrated an infrastructure for a service from serverless to serverful. We also got to see how I took an idea and then implemented serverless. So whether it's serverful or serverless is your approach, just go and build it. Just don't necessarily think of that it needs to be perfect, because it can be perfect at the moment that it works. It doesn't necessarily need to be the most complicated architecture. As long as it works and delivers the features that are needed, that's really all that matters. And of course, you can always optimize, you can always make it better, but time and complexity problem we discussed, we need to make sure that we can get the features into the hands of our users in the fastest way possible. So that's where serverless makes sense for us. Now, serverless event-driven architectures, we talked about the time and complexity issues. Then we also talked about how we have numerous infrastructure as code tool chains and services to help us build in a serverless way. Now, we use, like I said, Amplify and CDK and editing CloudFormation directly at the Capital, but feel free to use, serverless. I know a lot of developers like serverless, and also if you like SAM, it's another great way to use Lambdas to write. But find what works for you, and I would say just like try to build with the documentation. Find something that you like. I really like Amplify because I like what it does. I like what CDK can extend from Amplify, and then I also like just editing CloudFormation directly if there's stuff that neither of the two can do as efficiently. And then I also want to leave you with this idea that serverless isn't just Lambda. And that's actually something that I went into this thinking, oh, well, serverless is just a Lambda function. But then there's so many different ways that you can make events in your own architecture so that it isn't just Lambda. It can be Lambda working with a bunch of other services, or a bunch of other services working with Lambda. So I want us to just not necessarily think of serverless as a Lambda function, but it's a mindset. It's a vision for how you can build in the cloud. And that could be databases, queues, events, and more. So I'll leave the more for you all to decide some cool architecture patterns, and I'd love for you to let me know at some point what you end up building. So with that, I hope that this conversation was really helpful for you, and you're inspired to build.
Give it up for Brian. I'm going to try something really quick. If you can hear my voice and you have a smartphone, pull it out. Okay? You got one? All right. Come on, come on. All right. Scan the QR code and give Brian a review.